Let us understand the concept of composition of two forces by using parallelogram law. If we observe the diagram, there are two forces F1 and F2 which is having angle theta in between them. These two forces F1 and F2 lie in a single plane, and that's why these forces are coplanar forces. Now these two forces passing through a single point, and that's why these are the concurrent forces. Now we have to find out the resultant force for these two forces. So how to find out? So we will make here one construction, that is, from this point B I will draw a line parallel to F2. And from this point D I will draw a line parallel to F1. Now these two lines intersect at one single point, and this point will be point C. Now if we connect the point A and point C, then if we observe, this A, B, C, D is nothing but parallelogram, and this AC is the resultant R. So we can say that for these two forces F1 and F2, this is the resultant force R. Now this R is having angle alpha made with this force F1. So I will mention here angle alpha. Now how to find out the value for the resultant R? So again we will make one construction. I will extend this force AB, and we will draw the perpendicular on the extended line AB passing through the point C. So here is the point, and this point is nothing but E. So I will highlight this triangle. So this is the triangle BCE. If we observe, here is DAB, that is angle DAB is equal to angle CBE, because this is the extended line AB, and this F2, that is the line AD and BC, are parallel to each other. So this line BC indicates the force F2, and this line DC indicates the force F1. Now how to find out the resultant R? Now if we observe AC is equal to, if we observe the triangle ACE, then AC is equal to AE square plus CE square. Now we will split this AE. So AE is equal to AB plus BE. Now AB is equal to F1, that from the diagram we can write. Now what is the value of BE? So if we observe this triangle CBE, then this BE is equal to this BC into cos theta, because this angle is also equal to theta. So this line BE is nearby to angle theta, so this BE is equal to F2 cos of theta. Now what about CE? So it is opposite to angle theta, so CE is equal to this BC sin theta, that means F2 sin of theta. So in this way we will get the value. So we will again write here, that is resultant R is equal to, now instead of AE what we have to write, that is F1 plus this BE, that is F2 cos theta bracket square plus CE square, that means F2 sin theta bracket square. Now we will solve this. So here A plus B bracket square. So we know that A square plus 2AB plus B square. So we will write under root of F1 square plus 2 F1 F2 cos theta plus F2 square cos square theta plus F2 sin theta, that is F2 square sin square theta. Now this cos square theta plus, suppose we take F2 term as a common, then inside the bracket sin square theta plus cos square theta, and this sin square theta plus cos square theta is equal to 1. So simply we will write R is equal to under root of F1 square plus 2 F1 F2 plus F2 square. So if we observe 2 F1 F2, here will be cos of theta. So I forgot this. So F1 F2 cos of theta. So here F2 square as a common term, sin square theta plus cos square theta is equal to 1. Then F1 square plus 2 F1 F1 F2 cos of theta plus F2 square. So this is the final equation to find out the resultant R for the two forces. So if we observe these two forces is having angle theta in between them, then we have to use this formula. Now we will move next. We have to find out the alpha. That is the angle made by resultant R with the force F1, or we can say horizontal force. So tan of alpha is equal to, so from this triangle ACE again, CE divided by AE. That is CE divided by AB plus BE. So again CE, that means we can say that from this triangle we know the value of CE F2 sin theta. So we have to use same value, and BE we have shown here F2 cos theta, so we have to use here. So again alpha is equal to tan inverse of F2 sin theta divided by F1 plus F2 cos of theta. We will find out the value of resultant R when the angle theta is different in between the two forces F1 and F2. So first angle when theta is equal to 90 degree. That means F1 and F2 are perpendicular to each other. Then how to find out the value of R? So if we observe R is equal to, in this formula we have to put theta is equal to 90 degrees. So cos of 90, that is equal to 0. So this whole term will become 0, and R is equal to under root of F1 square plus F2 square. So when theta is equal to 90 degree, then we have to use this formula. Now next angle when theta is equal to 0 degree. So now cos of 0, that is equal to 1. So here cos of 0 is equal to 1. So this formula will become under root of F1 square plus 2F1 F2 plus F2 square. So this is the formula for A square plus 2AB plus B square. That means A plus B bracket square. So if I write here, which is equal to F1 plus F2, F1 plus F2 bracket square, and this under root as it is. Then this under root and this square is getting cancelled, and here is F1 plus F2. So this is the formula that we have to add these F1 and F2 forces. So if we observe this theta, that is angle in between the two forces, is 0 degree. So how to show this F1 plus F2? So addition of two forces, that is these are the concurrent forces. So here from this point I will show force F1, and within the same point we have to show the force F2 in the same direction because theta is 0 degree. That is F1 and F2. Now we will move next. That is when theta is equal to 180 degree. So cos of 180, that is equal to minus 1. So here F1 square minus 2F1 F2 plus F2 square. So this is the case of A square minus 2AB plus B square. So we will write here A minus B bracket square, that is F1 minus F2 bracket square, and this under root as it is. So this square root and square is getting cancelled. So here is only F1 minus F2. So these are the concurrent forces. So from this same point we have to show the two forces F1 and F2 but are opposite in direction, because if force F1 is having positive sign, then F2 is having negative sign. So I will show here force F1 and then in the opposite direction force F2.
Given question: the resultant of two forces, one of which is double the other, is 260 Newton. If the direction of the larger force is reversed and the other remains unaltered, the resultant reduces to 180 Newton. Determine the magnitude of forces and angle between the forces.
There are two forces F1 and F2, and the magnitude of resultant R is given for the two different conditions. We will understand the first condition. Magnitude of resultant R is 260 Newton when one force is double the other force. Now we will understand this. When F1 is equal to F, then the other force will be double. That means F2 is equal to 2F. So this condition is getting satisfied when resultant R is equal to 260 Newton. Now the second condition is given, that is the larger force is reversed. Then the value of resultant R is 180 Newton. Now in between this F1 and F2, which is the larger force, so this F2 is double the F1, that means F2 is the larger force. So we can say that when F2 is equal to minus 2F, because larger force is reversed, that means its direction is reversed. So it is having minus sign or negative sign. So F2 is equal to minus 2F, then R is equal to 180 Newton. Now for these two conditions we have to find out what is the value of F1 and F2 and what is the value of angle theta in between them. Now we will take the formula to calculate the resultant R for two forces which are coplanar as well as concurrent. So here R is equal to under root of F1 square plus 2 F1 F2 cos of theta plus F2 square. Now we will put the first condition. So when F1 is equal to F, so instead of F1 we have to put F, and instead of F2 we have to put 2F. So here under root of F square plus 2F. Now instead of F2, now for F2 value is 2F, so we have to take the bracket. In bracket 2F cos theta plus 2F bracket square. Now this under root remains same. So on the left hand side we have to put the value of R. Now we will take the square on both sides. So if we take the square on both sides, then here F square plus, now 2 multiplied by 2, that is 4, F multiplied by F, that is F square. So 4F square cos theta and 2F bracket square, that is 4F square. So we have to write this. Now this square root is getting cancelled because we have squared on both sides. So on the left hand side we have to write the value for square, and F square plus 4F square, that is 5F square plus 4F square cos theta, which is the equation number 1. Now in the same way we will put the value for the second condition. Now instead of F2 we have to put minus 2F. So we will put the value. So 180 is equal to under root of, now F1 remain as it is, that is F square plus 2F inside the bracket minus 2F cos theta plus minus 2F bracket square. Now we will simplify this. So we will take square on both sides. So 180 square is equal to the square root and square is getting cancelled. F square, now 2 multiplied by 2, 4. F multiplied by F, that is F square, and it is having minus sign. Minus 4F square cos of theta. Plus, now minus 2F square. So minus 2 is having square. Minus 2 multiplied by minus 2, that is 4. That is plus 4. That is here plus 4F square. So here F square plus 4F square, that is 5F square minus 4F square cos theta, and on the left hand side we have to make the square of 180. So this is the equation number 2. Now when we add these two equations, equation number 1 and equation number 2, then this 4F square cos theta and 4F square cos theta is having plus and minus sign. So it is getting cancelled. 5 square plus 5 square, that is 10F square, and when we add this, so here is the value. Therefore F is equal to 100 Newton. Now this F is nothing but F1. F1 is equal to 100 Newton. And what is the value of F2? So F2 is equal to 200 Newton. Now how to find out the value of theta? So we have the equation, that is R is equal to, or we can simply say this is the equation number 1. So if we put the value of F, that is equal to F1 in this equation, then we will get the answer for cos of theta. So theta is equal to 63.9 degrees.